Hello everyone, welcome back to the course Financial Mathematics for Actuaries. We are learning the bond pricing under term structure of interest rate. In the previous sessions, we have learned the spot interest rate and the forward interest rate. Now, let us also understand the bond pricing under the term structure of interest rate, or we will call under the general term structure of interest rate. So, having understood the spot rate and the forward rate, let us now understand the bond pricing under general term structure of interest rate. To do this, recall our bond basic price formula, which says that P is equal to FR A angle N at I plus C V to the power N. Okay. But this formula assumes that the term structure is flat. Okay. So, it assumes a flat term structure, that is the yield rate for all the cash flows, that is the coupon and redemption values are same. Okay. In the case when the term structure is not flat, the pricing formula has to be modified. Okay. So, let us now consider a bond with n coupon payment of amount C1, C2, Cn and the redemption value at the time n with redemption value C. Okay. So, also denote that IJS be the spot rate for the cash flow due in the J years and R be the rate of interest for coupon payment. Okay. The price of the bond, then the sum of the present values of the coupons and the redemption value. Right. Therefore, the annual coupon bond can be written as P is equal to sum of Cj upon 1 plus Ij s to the power j plus C upon 1 plus In s to the power n, which can also be written as, in terms of our earlier formula, we will have like take this Cj out, which is simply the Fr, and therefore, we will have like sum of 1 upon 1 plus Ijs to the power j plus G divided by 1 plus Ins to the power n. Okay. So, this is the formula for bond pricing under the general term structure, okay, assuming that interest rate is compounded annually. Okay. For a semi-annual label coupon bond, okay, we can just modify the formula as we will have like now the J is actually divided by 2 because it is semi-annual now, and therefore, the interest or the spot rate is now divided by 2. So, we can rewrite this formula simply, okay, just by dividing the spot rate, okay, by 2 if the bond is a semi-annual label coupon bond. Okay. So, let us understand this with a example. Okay. Let us consider the example that it says consider a $100 par value bond, okay, with coupon rate of 4% per annum paid semi-annually, okay, and the spot rate of interest in the market is given in this table. Here it says, okay, like it is half yearly. Okay. So, every half year it is given. So, J is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So, up to 5 years is given, and the interest rate, that is the spot interest rate for every half year actually is also given. Now, find the price of the bond if it matures in 3 years, and also find the price of the bond if it matures in 5 years. Okay. So, let us do that. So, the price of the bond if it matures in 3 years therefore, can be computed by using the same formula, okay, that P is equal to FR sum of 1 upon 1 plus IJS plus C upon 1 plus INS, okay, and considering you have already computed the semi-annual rate. Okay. So, therefore, F is what? F is the face value which is 100 and R is the rate of interest or the coupon rate of interest which is 4% divided by 2 will be like 2% and therefore, we have written here 0.02 multiplied by, okay, 1 upon 1 plus R, okay, 1 plus this spot interest rate, okay, this one while divided by 2. So, every time we have dividing it by 2 and then we have proceeded, right, and therefore, n is here what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right. Okay. So, we will have here in the first year therefore, 1 divided by 1.015, okay, to the power 1 is nothing, okay, but 1.015 plus 1 upon 1.015, okay, this is for this one, right, and then, okay, to the power 2 plus 1 upon 1.0175 to the power 3. Okay. So, this 0.175 will be computed from here, right. Okay. So, similarly, we have just put it for all the value for 3 years. So, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6 till here, okay. To till here we are now computing, right, and then therefore, here n is equal to 6 and we are now computing that when n is 4% divided by 2, okay, this one, right, is 2% and we have used it here, okay, for this value, this part of the value, right, and upon computing here we will compute one by one and then we will get the value, okay. So, 100 multiplied by 0.02 will become 2 and then 1 upon 1.015 will become, this 0.9852. I have taken only 4 decimal point here and then like this is like again 1 upon 1.015 square will become this one, and similarly I have computed for all this value, okay, and then 100 upon 1.02 to the power 6 will be 88.7971, okay. So, this will give me a value of $100.0601, okay. So, what this says? It says that this value, this is the price, this is equal to the price which is greater than the face value, okay. We have got it. So, price is greater than the face value if we have computed the 3 years bond, okay. The price of the bond if it mature in 3 years then it will give us 100.060, okay. Similarly, we can compute it for 5 years also, right. So, take the same information here and also compute it for 5 years. Now, we have to consider n is equal to 10 here, okay, up to 10 and then proceed accordingly, right, using the same formula here, and therefore, I have now put it for all 10 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right, and then this is the final value, that is 100 divided by 1.025, that is divided by 2 is equal to 0.25, and this value is directly taken as I have already told you. Okay. So, once you do this, you will get the value for each of the term here, and therefore, we will write that P is equal to 2 multiplied by 0.9852 plus 0.9706 plus 0.9492 plus 0.9329 plus 0.9057 and do it up to 10. Okay. Here, and then like plus this 100 divided by 1.025, okay, to the power 10 will give me the value of 78, okay, or 78.1198, taking the 4 point, okay, 4 numbers after the decimal. Okay. Now, rounding it, we will just take. So, upon computation we will have 95.9316. So, this value is less than the face value. So, this is the P here, and therefore, this is less than the face value, right. Okay. So, what we have observed here? What we have observed here is when the spot rate of interest are less than the coupon rate, okay, that is for less than 3 years, okay, we have P is greater than FV, or the price is greater than the face value, which is for a premium bond. Okay. So, we will get a premium bond if the price is greater than the face value. We have learnt it several times. Okay. So, when the spot interest rate, okay, are less than the coupon interest rate, then the bond is said to be a premium bond, or most likely the bond will be, or the price will be higher than the face value. On the other hand, when the spot rate of interest are higher than the coupon rate, see it here, okay, after this, okay, after here, okay, after this one, we can say like the spot interest rate is higher than, so the coupon rate is 4%, okay, and therefore, these are more than 4%, okay, 3 years afterwards, right. So, when the spot rate of interest are higher than the coupon rate, we have the price which is less than face value. In such case, the bond is known as a discount bond. Okay. This also you have already understood several times, right. When the term structure is not flat, the premium or the discount relationship of a bond with respect to its redemption value may vary with the time to maturity, even for the bond with the same coupon rate, that we have seen. Okay. So, the term structure is not flat, okay, or when the term structure is not flat, the basic bond price formula does not hold. Okay. But the principle of pricing of bond at the present value of the coupon and the redemption payment still applies. So, we can apply the present value calculation method, okay, here, and the present values are evaluated based on the market term structure, right. Let us now move forward to understand the other aspects, that are how to compute the par yield, and eventually we will also understand the computation of holding period yield. Okay. So, what is par yield and how to compute the par yield, right. Remember that the yield to maturity is the internal rate of return of the bond investment. We have already understood how to compute the current yield and how to compute the yield to maturity, okay, and we have understood there that the yield to maturity, okay, that is IY, is just the solution of our equation, this one, okay, or the present value equation here, that is P is equal to FR sum of 1 upon 1 plus IY to the power j plus C divided by 1 plus Iy to the power n here. From this equation we will compute this, or we will solve for this Iy, and that will become the yield to maturity. Okay. We have done that using the trial and error methods, and also we have understood this calculation of yield to maturity by considering one approximation formula. Okay. So, given the prevailing spot rate curve and the bonds are priced according to the existing term structure, the yield to maturity Iy is solved from the following equation. Okay. So, this one then will become equal to FR, okay, sum of 1 upon 1 plus this one become the, okay, 1 upon 1 plus I j to the power j plus c divided by 1 plus I n to the power n. So, what is this I j s here? Okay, this I j here, these are the spot rate, okay, and therefore, this is the term structure, right. So, this is the existing term market term structure, okay, or this equation is based on the existing market term structure, right. So, let us rewrite again the same equation and understand this equation. So, Iy is a non-linear function of averaging the spot rate, okay, that is Ij when j is equal to 1 to n, this one, right. So, as an averaging measure of the spot rates, however, this yield to maturity has some disadvantage. What are the disadvantage? The disadvantage is that we do not have any analytic solution for Iy, okay, and it has to be computed using the numerical methods. And also secondly, Iy or the yield to maturity varies with the coupon rate of interest, even for the bonds with the same maturity, right. We have seen that already. So, to overcome these difficulties, the par yield may be used. So, it is the coupon rate of interest such that the bond is traded at par based on the prevailing term structure, this one, okay, based on the prevailing term structure, the bond is sold at the par, right. Therefore, denoting the par yield by IP and setting the face value is equal to the redemption value is equal to 100, we can rewrite the formula as 100 is equal to 100 multiplied by now IP, okay, multiplied by sum of 1 upon 1 plus Ijs to the power j plus 100 divided by 1 plus I n to the power n. Now, go on solve for IP and we will get the par yield. Okay. So, we can now solve for this IP as, okay, IP is equal to here 1 minus 1 upon 1 plus I n s to the power n whole divided by summation of 1 upon 1 plus I j s to the power j. Okay. That is here, like you have just taken this 100 out here, and therefore, this 100 divided by 100 will become 1, and therefore, you will get IP is equal to 1 minus this one, okay, divided by this sum. This can also be written as 1 minus 1 plus I n s to the power minus 1 minus n whole divided by summation of, okay, 1 plus I j s to the power minus j in this way, right. So, this equation therefore can be written as this equation. So, IP is equal to 1 minus 1 plus I n s to the power minus n divided by sum of 1 plus I j to the power minus j. Okay. So, this formula will become the formula for yield for or par yield, or when the bond is sold at par, right. So, let us now understand what is holding period yield. Note that bonds are actively traded in the secondary market, and for various reasons investors often sell their bonds before the maturity, and therefore they are concerned about how much return they are going to get, okay, when he sell it. Okay. That is the holding period, the period when they hold the bond, right. So, the holding period yield, also known as the realized compound yield or the total return, is often computed on an ex post basis to evaluate the average return of the investment over the holding period of the bond. So, let us denote the holding period yield of a bond by IH, okay, and suppose a bond is purchased at time t minus 1 for a price p t minus 1. So, p t minus 1 is the price for the time t minus 1. Okay. At time t, bondholder receives a coupon of FR and then sell the bond for PT. So, he will get a coupon of FR and also he will sell the bond at price PT at time t. Okay. So, the holding yield over the period t minus 1 to t denoted by IH is then computed as IH is equal to this price of at the time of t plus whatever coupon amount he has got, okay, minus the price of the previous term divided by price of the previous term, that is PT plus FR minus PT minus 1 divided by PT minus 1. Okay. So, this is the holding period yield, okay, for one if the investors hold the bond for one period. Okay. So, let us understand this by considering one simple example. Okay. So, a $1,000 face value, okay, 3-year bond with semi-annual coupon at 5% per annum is traded at the yield of 4% per annum convertible semi-annually. If the interest rate remains unchanged in the next 3 years, find the holding period yield at the third half year period. Okay. So, understand the question very clearly first, then the answer will be very simple here. The question says a 1000 rupees or $1,000 face value bond, okay, having a 3-year maturity, okay. The coupon rate is 5% per annum, okay, compounded semi-annually, traded at the yield of 4% per annum, which is converted or convertible semi-annually, and if the interest rate remains unchanged in the next 3 years, then we have to find out what is the holding period at the third half year period. Okay. So, the solution now, we first compute the price of the bond after the second and third coupon payment using our basic price formula. Okay. That is, we have to compute the P2 here, okay, that is the second period price and the third period price. Okay. So, second period price, the n will become 4, right, 2 multiplied by 2, right, and therefore, we have simply computed here, okay, this one is FR, okay, FR, that is 1000 multiplied by, okay, the coupon rate here, that is 5% divided by 2. So, we will get it like FR is equal to 25. Okay. So, 25 multiplied by A angle 4 at 0.02 plus 1000, okay, V to the power 4. Okay. Now, you have already understood the formula here. This is the annuity factor and this is the present value factor, and therefore, using the same formula we will get 1019.04. Similarly, we will compute it for we will compute the price for third period. Okay, in third period, therefore, again 3 multiplied by 2 will become 6. So, n is equal to 6 here, okay, and the yield rate is like 4 divided by 2, so we will have 0.02 similarly here, okay, or similar to here, right. So, 25 multiplied by, okay, or 25 times A angle 6 at 0.02 plus 1000 V to the power 6, we will give we will get the value of 1014.42. Now, after getting this P2 and P3, you can use the formula for the holding period and then we can easily compute it, right. The holding period yield for the third half year therefore is, right, this is the, okay, P3 here, okay. So, P3 here, right, plus FR here minus this is P2 here, okay, and divided by P2 we will get this one. So, rounded it up to 2%. So, the holding period yield therefore is computed as to be 2% for our problem here, right. Now, we can extend this formula to n period holding yield. So, in order to calculate the n period holding yield over n coupon payment period, we need to know the interest earned by the coupon when they are paid. Okay. So, let us denote P0 is the beginning price, okay, of the bond and Pn is the ending price of the bond and V is the accumulated value of the coupon, okay, at time n, and the n period holding period IH is then the solution for the equation P0, okay, time 1 plus IH to the power n, which is equal to Pn plus V. Okay. Now, you can solve it for IH and we will get that IH is equal to Pn plus V divided by P0, okay, to the power 1 upon n whole minus 1. Okay. From this equation we can solve it for IH, you will get this equation, that is the annualized n period holding yield. So, annualized n period holding yield is simply Pn plus V divided by P0 to the power 1 upon n. So, let us also take one example to complete this and we will be done. Okay. So, consider a 1000 rupees face value bond, okay, 5 year to maturity non callable bond, okay, with annual coupon rate of 5%. An investor bought the bond at its issue date at a price of 980. After receiving the third coupon payment, the investor immediately sold the bond for 1050. Okay. The investor deposited all coupon income in a saving account earning an effective rate of 2% per annum. Find the annualized holding period yield of the investor. So, how to do that? Now, so we have here what is the P0 and what is the P3, right. So, we have P0 is equal to 980 and P3 is equal to 1050, this is this one and this one, okay, that is the after receiving the third coupon payment the investor immediately sold. So, this is the selling price, okay, and this is the buying price 980. So, the accumulated interest rate on interest or the accumulated interest on interest of the coupons, okay, that is V, can be computed as 1000 multiplied by 0.05, okay, of S angle 3 at 0.02, right, which is equal to 50 multiplied by 3.0604, okay, which is equal to 153. So, once you compute the P0, P3 and V, your job is done now. We can easily compute what is IH. Okay. So, the annualized 3 period IH is the solution of our equation, this one, right. So, we have 980, right, time 1 plus IH to the power 3 is equal to 1050 plus 153.02. Now, we can solve it for IH, which will become ith will be like we will have 1203.02 divided by 980 to the power 1 upon 3 minus 1, which will give us 7.0736%. So, the holding period yield in this case is 7.07%. So, now that we have understood how to compute the yield to maturity, the current yield and the par yield and the holding period yield given the term structure of interest rate. And in this week we have also understood the spot rate, forward rate and the yield curve and also the theories that explain the term structure facts, right. I believe we have now understood most of the concepts related to bonds and bond pricing. In the next session, we will be discussing some topics that are related to bond management. See you in the next session. Thank you.